still love Jews.
Buy yourself a new shirt.
You want me to go psycho? Mission accomplished.
Hold on.
Hey, what's up? I don't know what's up with my camera. I know you can hear me though, right? Yeah, I saw that. I saw that. I had to take a day off. I don't know what's up with my camera. Stand by. I'm trying to figure it out. I don't know what the deal is. It was working 5 seconds ago. Yeah. Sound probably is good. That's fine. But my camera's not working. I recorded all kinds of videos earlier. It was working fine. Hold on. Stand by. Maybe if I remove it and re-put it back. I don't know. Let me see. Video capture device. Active existing. My camera. I realize you can see me doing this. I don't care. You can just wait a second. Hold on. I'm gonna have an electric start. Just give me a second. Hold on. Um, my webcam, and that needs to go all the way down here. And this, come on, you can do it. There's like 60 people watching me. Let's go. Chop chop. Okay, there we go. Right there. All right, and then it needs to go to the bottom of this. Okay. All right. Good enough. Okay. Good enough. Are we good? Are we good now? Can I start my damn show, please? $250 webcam. I just got a brand new computer. What? Hey, what's up? How you doing? I've been making videos all day and I'm bored, and I was going to look up updates about my favorite subject, the interstellar object 3I Atlas that's on its way hurtling towards Mars and Earth. So I figured, why not see if somebody wants to watch this with me? I got 75 people for this. Hell yeah. Welcome. I cannot believe I have 75. Yay. That's good. I am not Portland Climatics, okay? I am not a restreamer. I just happen to have found that niche, and now I found all of you. So I am a all things interstellar, outer space. I am all things political. I want to cover a broad variety of subjects, okay? So I saw let's talk about last night. I had to take a night off. I had to spend some time with my daughter. Well, I wanted to spend some time with my daughter. I wanted to spend some family movie night type of thing, you know? I saw that Stolen Valor was laughing about making fun of people getting arrested, and then he got arrested. That's the world line. That's like the universe lining up perfectly. You know what I mean? That's okay. You got outer space in the background. Now, if you did not know, I'm really into space. I have a bachelor's degree in psychology, but during that time, I was given the option of taking many science classes. So I took three college classes on black holes, one on interstellar objects, one on astrophysics, and I'm really, really into this. In fact, I've said a few times that I have a huge tattoo on my leg. Half of it is outer space. So, what's up, everybody? What's up, Jessica? What's up, Jim Brown? What's going on, guys? So, also, I added a wood chipper emoji. Members, have fun. So today, if you don't know, You remember that interstellar object that was like a Muamua or whatever, the long thing that was hurtling itself towards like Pluto area? Well, this object here called 3I Atlas, it's called 3I because it's the third interstellar object that's entered our solar system, right? It's the size of Manhattan. And it's doing weird things, like it started glowing green out of nowhere. It has, you know, usually when a comet or an asteroid is hurtling somewhere, it has a tail in the back. You know, you see like a cartoon. You see something hurtling, it's got the tail in the back. This has a tail in the front, which is weird. It was slowing down, speeding up, and changing speeds as if it was a ship. I'm not saying it is a ship, but it has extremely weird characteristics. So if you've never heard of this, I have a couple videos pulled up. It'll be a couple hour stream, and we're gonna all learn about this. The point here is to turn this into a video, okay? So I'm gonna be saving the chat, and I'm gonna try to put the chat in the little empty space maybe above me. So have at it, and let's learn about 3I Atlas. Thanks for being here with me for this. It should be really interesting. It's a nice little step away from the Portland protests and the Chicago stuff, and everything's going crazy. And I just needed like a mental break. I wanted to stream. I didn't think people would want to watch me play Hearthstone or Call of Duty or something. So I figured, let's try this. So thank you so much again for being here. We have 100 people, and that's awesome. Let's get on with the show.
There is a very strange object flying past our sun. We don't exactly know what this thing is or what it's doing. We can't even see it anymore. But we have been watching this object very closely for months. We've given it a name, 3I Atlas, and we've given it a title, Interstellar Comet. There is a lot that we know about this new visitor to our solar system. In just 4 months, there have been nearly 100 research papers published on 3I Atlas, and there is plenty of other information out there that doesn't appear on the official record.
I know Jessica said something. I got to stop just for a second. Hi, Jessica. How you doing? All right. So I will be live later tonight for the Portland crazy furry party idiot thing that they're doing. Okay. I was bored. I wanted to stream during the day here today for a little while. We'll do a couple hours with this 3I Atlas. Then I'll shut everything down. I'll go, clean the kitchen and do the laundry. And then I'll be back later on tonight for the Portland. So don't worry. We're going to get our fix of Portland weirdos today, guys.
Some of it can sound pretty insane. So today, we're going to cut through the noise, and we are getting to the bottom of everything you actually need to know about 3I Atlas. Let's talk about the journey of this interstellar object.
Ooh, Frank.
Right now, 3I Atlas is making its closest approach to the sun. We call this phase perihelion, and the peak occurs on October 29th when the object will pass within about 210 million kilometers of our star. Although in space, we typically use a larger form of measurement. That's the astronomical unit, or AU. 1 AU represents the average distance between the Earth and the Sun, which helps us to bring a familiar sense of scale to the vastness of the solar system. So the perihelion of 3I Atlas occurs at 1.4 astronomical units away from the Sun, which means it doesn't actually get that close. It's somewhere just inside the orbit of Mars. But this will be the time of peak activity for 3I Atlas. This is the hottest that it will get, which means that a lot of material from the surface of the object is going to get blasted out into space. Now, that's normal for a comet. We call this process sublimation. It's what happens when a solid material transitions directly into a gas, because there's no liquid in the vacuum of space. And sublimation is what gives a comet its distinct look, with a fuzzy halo and a long tail. The halo is made of all the gas and dust being ejected from the hard surface of the object. It's technically known as the coma. The tail is created by solar wind. That's a name for the waves of radiation that constantly flow from the surface of the sun. This wind blows back all of the lightest bits of dust and gas from the coma and pushes it away from the comet. It's a spectacular piece of cosmic ballet, and unfortunately, we don't get to see this happening to 3I Atlas as it flies through its peak exposure to the sun because we are on the wrong side. Call it fate or call it something else, our view of the perihelion is completely blocked out by the glare of the sun. Okay, so we know where 3I Atlas is right now, and we have a pretty good idea of what it's doing, so while we wait for it to reappear on the other side, that gives us an opportunity to investigate how it got here in the first place, and this is a deeply fascinating story. We have been tracking 3I Atlas since July 2025. It was officially spotted by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, which is actually a bunch of telescopes all around the world in places like Hawaii, Chile, and South Africa. What they do is stare at the night sky and look for moving objects. And that is what they saw on the night of July 1st, just another moving object. So they classify it as a new asteroid and they're ready to move on. But then they notice something weird about this one. It's moving too fast. Everything in space is constantly in motion, and every object in the solar system rotates around the sun because we are all trapped by its force of gravity. The fact that we are moving is what keeps us from falling into the well of gravity, and the closer you get to the sun, the faster you have to move in order to stay afloat. But if you start to move fast enough, then you actually start to rise up out of the well. And if you reach a certain velocity, then you break free completely of the sun's gravity and you can fly out into interstellar space. You enter the void of nothingness that exists between stars. And when astronomers clocked the velocity of this new asteroid, they were shocked. This was the fastest moving object ever detected in our solar system. Let's establish some scale here. The planet Earth orbits the sun at a speed of 30 kilometers per second. That's us. We're moving pretty fast and we're pretty close to the sun. But there are planets that are a lot closer. Here is Mercury, 0.4 astronomical units from the surface of the sun. It gets cooked, and to avoid falling into the gravity well, Mercury has to orbit at a velocity of around 48 kilometers per second. The new object discovered by Atlas was moving at 58 kilometers per second, and at the time, it was still way out there, just inside the orbit of Jupiter. That's about 4.5 AU away from the sun. And at that speed, it was clear that this object was going to blow straight past the sun and just keep on going. We call this a hyperbolic trajectory, meaning that this thing had come from the void, from interstellar space, and that's where it was going to return after completing its grand tour of our solar system. This is when the name 3I Atlas came to be, Third Interstellar Object, which means there were two before it. You probably know this one, Oumuamua, the first ever identified interstellar visitor, and it was also pretty weird, although it was weird in a totally different way than Atlas is, and we'll get deeper into that very soon. But we also have a second interstellar object, the often overlooked middle child, 2I Borisov, which was actually not that weird. Aside from the fact that it was interstellar, it basically just acted like a normal comet. So if anything, it was weirdly not weird. There are three big differences between 3I Atlas and its interstellar siblings. One is size. It's literally much bigger. Oumuamua was up to 400 meters across. Borisov was as wide as 1 kilometer, but 3I Atlas could be up to 5.6 kilometers in width. 2 is speed. Atlas travels at about double the velocity of Oumuamua and Borisov. And 3 is the direction that the object came from. And this is the really weird one. Oumuamua came in from above, from the northern sky, which is the general direction that the solar system is moving. So we're all orbiting the sun, but the sun itself is also orbiting around the center of the Milky Way galaxy, and it's dragging us along with it. So as much as Oumuamua hit us, we also kind of ran into it. 2I Borisov did mostly the same thing. It came in at more of a diagonal angle than straight on, but from the same general direction. Now, 3I Atlas is not another head-on collision. This one is a T-bone, and it's coming in on that side angle in almost perfect alignment with all of the planets. Our solar system is like a disk of stuff that all formed around the sun. Over time, all of that stuff kept smashing into each other and forming into planets and moons and asteroids and things, but it all remained in a relatively flat disk shape. We call that disk the plane of the ecliptic. There are only a few things that are a little bit offset from that plane. The most recognizable one would be Pluto. Its orbit is tilted by 17 degrees, so sometimes it's a little above the plane of the ecliptic and sometimes it's below. It's important to know that so we can appreciate how well aligned 3i Atlas actually is.
Oh, by the way, if you're wondering what's on my wall, because it's hard to see, I usually have the flag up there. That's a live stream from NASA, from the International Space Station. It's live right now.
The interstellar object is only 3 degrees off from that ecliptic plane. It hit our solar system in perfect alignment with the disk. Space is three-dimensional, and that object could have come from any direction. So to have something hit us almost perfectly side-on, it's a very big coincidence. But that leads us into an even bigger question. Where did 3i Atlas come from? Well, we know that it came from the direction of the galactic core. So if we look at the Milky Way galaxy from this usual top-down perspective, you are here in this kind of outer half of the galaxy, located in a spiral arm. When you see the Milky Way in the night sky, that's the next spiral arm over. Anyway, 3i Atlas came from the direction of this bright core in the middle. It's bright because it's full of stars and they're packed together much more tightly than the ones in our neighborhood. But again, space is three-dimensional, so to really understand where 3i Atlas originated, we need to flip the galaxy over to a side view. And just like our solar system, most of the stuff in the Milky Way is concentrated in a thin disk around the core. But also like our solar system, there are a few things that kind of hang out above and below the thin disk. In the galaxy, we call that area the thick disk. It's a lot less crowded in the thick disk, so you don't get nearly as many giant collisions and
I swear to God, I thought he said something else.
supernova explosions and black holes and stuff. So things in this region tend to just hang out undisturbed for very long periods of time. And that's where astronomers believe 3i Atlas came from, this ancient region of space, which could make it as old as 7.6 billion years, nearly
like
twice the age of our own planet.
Let's see.
Now, we'll probably never be able to trace
Bunch
the
of
journey
nerds.
of 3i Atlas all the way back to its point of origin, but astronomers have recently managed to backtrack over 10 million years, and they've identified 93 stars that the object would have encountered over that period. But what's deeply fascinating is that over the course of that 10 million years, the closest it would have come to any of those 93 other stars was a distance of 0.3 light years. That's 63,000 astronomical units. And right now, 3i Atlas is just 1.4 AU away from our own sun. Now let's talk a little bit more about how 3i Atlas approached the sun and what we learned about it along the way. Even though 3i Atlas was officially discovered on July 1st, it was actually spotted for the first time on May 7th, 2025. It showed up in images captured by the Transiting Exoplanet Survey Satellite, or TESS. It's an observatory that orbits the Earth and looks deep into the galaxy, trying to identify new planets in other star systems. And for a period of about 1 month, TESS just happened to be looking in the direction of 3i Atlas. This gave us the opportunity to track the object as it moved through the orbit of Jupiter. The first thing that astronomers wanted to measure was the object's brightness and how it changed over time. That's going to tell us about what this thing is made of. We know that in the 1 month period that 3i Atlas was observed by TESS, it traveled about 1 AU in the direction of the sun. So extreme negative polarization of any object ever discovered. That is pretty weird, and it's just one of the many oddities about 3i Atlas that tells us not all solar systems are the same. What we think is normal here would be weird somewhere else, and what's normal in a different star system is considered weird around here. And then the second surprising thing about the coma of 3i Atlas was the fact that it even existed at all. Remember, we're looking at this period between May and June, and 3i Atlas is still way out there beyond the orbit of Jupiter. This is over 5 AU away from the sun. It's cold out there. It's so cold that we don't typically spot comets at 5 AU because they typically have not begun to form their coma yet. They're still frozen solid. It's not usually until somewhere between 3 and 4 AU that the sublimation process really kicks in. And that's because typical comets from our solar system are typically made of water ice, which needs a lot of energy to melt. But as we continued to observe 3I Atlas and we started pointing our most powerful telescopes directly at it, we learned that the coma was actually dominated by CO2 gas.
Wow, really, Colleen? That's awesome. I used to have my telescope plugged into a laptop, and I used to forget the club, forget going out. I would stay in and out in the backyard all night. It was awesome.
It did have some water vapor, but the ratio of CO2 was much higher at around 8:1. That's basically the opposite or inverse of what we are used to finding in comets. If you've ever seen dry ice before, it's typically used to create a smoky effect for live performances. That's frozen CO2. It has to be created and stored at incredibly cold temperatures. And as soon as it's removed from the deep freeze, dry ice will instantly begin to sublimate, making that signature cloud of gas. That is what 3I Atlas was doing way out there in space. And that's why its coma formed so early, because CO2 ice melts at a much lower temperature than water ice. And we've continued to observe 3I Atlas on its approach to the sun. We've seen that ratio of CO2 and water begin to flip. By late in September, as it was passing through the orbit of Mars at just over 1.5 AU, the object had actually begun to release a massive amount of water vapor, about the equivalent of a fire hose running at full blast, which is actually more water than we would expect even from a normal comet at this distance. We've never seen so much water vapor appear so suddenly. The same thing can be said for metal in the coma of 3I Atlas.
Fun fact, in the 80s, I believe 88 or something, while I was living in Georgia, I got a chance to go out with my parents and go see Halley's Comet. I remember, I was a kid. It was awesome. That's what kind of started my love for space.
When it was observed over the summer, astronomers detected a small amount of nickel in the surrounding cloud, but they did not detect any iron. So a couple of things to note here. One is that nickel and iron are pretty common in the universe because they are formed inside the core of a dying star. Then that star goes supernova and blasts these metals out into the surrounding area of space, where it gets pulled in by new stars that are beginning to form their own planetary disk, and then the process repeats. So because nickel and iron come from the same place, they're typically found together in planets, moons, asteroids, and comets. So when we see a lot of nickel but no iron, we wonder where the iron went, what process separated them. And thing number two, it's weird to see any metal at all sublimating from 3I Atlas given its distance to the sun when this observation was made.
My camera went off
again?
It's
still way out beyond Mars in the region of the asteroid belt, which is still very cold, and the process of sublimation is driven by heat. Now, when it comes to CO2, we know that it doesn't need much heat in order to melt.
Don't worry about that.
But when we're talking about metal, there's something else going on. Likely, the massive release of CO2 is dragging nickel atoms along with it, but that still doesn't account for the iron deficiency. Now, just like water vapor made a very sudden appearance in the coma of 3I Atlas.
Okay, so Colleen, we're going to watch several videos on it. This video here was produced 13 days ago, and this is just sort of like what is 3I Atlas. But I have a video here we're going to watch that was a stream of an astrophysicist that I watch, and that was from like a couple hours ago. So very, very recent. We're getting to it.
The same thing did eventually happen with iron. By late into September, astronomers had started to detect iron for the first time in the coma. And then, very quickly, the ratio of nickel to iron changed to a more normal combination of the two. So 3I Atlas is becoming more normal over time, but it's getting there in a very strange way. Now, let's talk about tails. This is another area where 3I Atlas has behaved a little different from your average comet. And that's mostly because the first time we saw a tail forming around 3I Atlas back in the summer, it was pointing in the wrong direction. This object initially formed a sun-facing tail. This is unusual because the tail is considered to be an effect of the solar wind interacting with the coma. The solar wind blows away from the sun, so therefore we expect the tail to flow in that direction. In this case, it didn't, which could be related to the early formation of the coma, which was due to the high CO2 concentration. Because the object began sublimating at a very long distance from the sun, it's possible that the solar wind just wasn't strong enough yet to push the cloud of gas and dust away. So what we saw was more of that cloud accumulating on the warm side of the object, the sun-facing side, before it encountered a strong enough wind to form a conventional tail, which is what 3I Atlas eventually did. By September, a short fan-shaped tail facing away from the sun had developed, which is pretty normal. Not all comets have long streaking tails like what we're used to seeing in illustrations. The length of the tail varies according to what the comet is made of and its distance to the sun. For example, Hale-Bopp is pretty famous for having a gigantic tail when it was observed in 1997, but it was also very close to the sun at that time, about 0.9 AU, 1/2 of an AU closer than 3I Atlas will ever get to the sun. So, of course, it experienced more sublimation and solar wind, which shaped that tail. And it's around this time that we actually get our closest possible observation of 3I Atlas, but the view doesn't come from the Earth, it comes from Mars. On October 3rd, the object passes within 0.19 AU of the planet Mars, the closest it will come to any planet in the solar system. And this is lucky for us because we have a lot of cameras on and around the red planet, which means we were able to use them to image 3I Atlas. Here is a photograph taken by the Perseverance rover from the surface of Mars. This is how the object would have appeared in the night sky. It's not a great picture, this isn't what the rover's camera was designed for, and in order to see this much light, the camera had to take 30-second long exposures, then several of those images were stacked on top of each other, so what you end up with is more like a streak than a defined object. And here is another image of 3I Atlas taken by the European Space Agency's ExoMars probe, which hangs out in orbit around Mars. We can see the object a little more clearly now, but there's still not enough resolution to distinguish between the bright coma and the surface of the object itself. In order to get that fine detail, we would need to take a photo with NASA's Mars Reconnaissance Orbiter, which has the most powerful telescope in the Mars system. Unfortunately, at the time we are making this video, that image has not been released, if it was even taken at all. Basically, there's been a shutdown of the US government, and people at NASA aren't going to work until some political stuff gets resolved, which...
Ginger, no worries. Not everything is an amazing, catastrophic event, right? Sometimes I just want to learn some new stuff, and I was just bored. I wanted to stream, but there was nothing going on, and not yet, at least in Portland. So you guys saw my couple of videos, right? They permanently blocked the National Guard. You heard that? Permanently blocked. I guess Trump is not a king after all, huh? Since these judges keep telling them what to do. See, that's another stream. We're getting to it. We're getting to it later on tonight. Later on.
Unfortunately could take some time.
I got my other hat ready.
Time is something that we have right now because the sun is going to continue blocking our view of 3I Atlas until early December, at which point we'll be able to study the effect that the sun had on the object, although the closest that we'll get is still 1.AU. That happens on December 19th. At this point, 3I Atlas will be well on its way out of the solar system, but there is just one more close encounter still to come. On March 16th, 2026, the object will fly within 0.36 AU of Jupiter. While we don't have nearly as many cameras around Jupiter as we do at Mars, we do have one. It's on a probe called Juno, which has spent the past decade observing the gas giant and its moons, but it will have a chance to take one last image of 3I Atlas before it disappears. Now, at this distance, the object will be cooling down. It's going to be less active, but it could be changed by its exposure to the sun, and that will add an extra layer of understanding to these interstellar objects. It's entirely possible that a lot of these strange characteristics didn't even come from the place where the object was formed. It's just an accumulation of weird stuff that it picked up along the way. For now, we can only wonder, but more answers, and probably more questions, are soon to come.
Okay. So now, don't worry, I'm prepared. I got lots of videos. I'm already ready for you. I'm ready for you. I'm ready. So here we have a couple of quick news stories. This one, the name of it says 3i Atlas caught NASA and Congress off guard. What's happening now? This was made, Colleen, 16 hours ago. It's 10 minutes long. We're going to watch this. You ready?
Amid the ongoing U.S. government shutdown, NASA scientists are continuing to monitor the interstellar.
Hold on. Since we're bragging about dads being involved, my dad was an electrical engineer and he worked at Cape Canaveral on the actual launch to the moon. He worked at the place, at the actual thing. Security clearances and all. Fact.
Stellar comet 3I Atlas, even as much of the agency's public communication remains paused. This week, NASA officials are preparing to brief Congresswoman Anna Paulina Luna, who formally requested new images and data to be released for public analysis. Meanwhile, Harvard astrophysicist Avi Loeb has renewed his call for transparency, citing fresh signs of brightening and non-gravitational motion after the comet's recent solar pass. Global observatories have launched a joint monitoring campaign through early 2026 to study the object's behavior as it recedes from the sun. Let's get started. Since its identification in mid-2025 as an interstellar visitor, 3I Atlas has moved steadily through the inner solar system, passing its closest point to the sun on October 29th. Around that time, astronomers recorded a sudden surge in brightness, suggesting intense
October 29th, as in like 10 days ago. Wait, 12 days ago. Something like that, right?
outgassing as sunlight struck previously shadowed ices. Spectral data hinted at brief jets of water vapor, carbon compounds, and trace metals venting into space. While these phenomena are normal for comets, what caught scientists' attention was the pattern of the acceleration, not fully consistent with models of uniform outgassing. The object's motion showed small, irregular shifts, prompting researchers to refine its orbit and rotation models. Such deviations are not evidence of anything artificial, but they provide valuable insight into how interstellar material behaves under solar radiation. Despite the federal shutdown, NASA's internal teams at the Goddard Space Flight Center and the Jet Propulsion Laboratory have maintained essential tracking. A briefing with Representative Luna was scheduled to discuss upcoming data releases and to reassure Congress that monitoring continues uninterrupted. Luna's office confirmed that the request came in coordination with a Harvard scientist, understood to be Avi Loeb, who has been pressing for open access to the newest images. At the same time, the European Space Agency and several university-run observatories have joined the observation network. The object is now roughly 300 million miles from Earth and fading, but high-sensitivity telescopes can still collect spectra to determine how its coma, the gas and dust envelope, evolves as solar heating diminishes. This phase is crucial. The comet's outward trajectory and changing light curve will help researchers model its density, spin rate, and internal composition. Those data will feed into the International Asteroid Warning Network's campaign.
Steven, it might be a bug, asteroid, or an alien probe. Thanks for the $2, man. I appreciate it. Hey, guys, it's funny that you would mention Elon. Stand by. The clip of what Elon Musk thinks is next. How did you know? That's crazy.
Campaign, running from November 2025 through January 2026, which aims to build the most complete data set yet on an interstellar body before it vanishes back into deep space. The renewed attention on 3I Atlas isn't simply because it's rare, it's because it represents a living laboratory for testing theories about how planetary systems exchange material. Spectroscopic measurements indicate that its ice and dust share similarities with comets from our own Kuiper Belt, Yet some ratios, particularly carbon to oxygen and nitrogen-bearing compounds, appear distinct. These differences suggest it likely formed in a colder, more distant protoplanetary disk, perhaps around a small, faint star.
Alien invasion.
Understanding those details could refine models of how water and organics migrate across the galaxy. If 3I Atlas contains isotopic ratios outside solar system norms, it would confirm that the chemical diversity between stellar systems is broader than previously thought, an important clue for theories of panspermia and early planet formation. The comet's irregular acceleration remains a technical point of discussion. Most researchers attribute it to asymmetric venting from the nucleus, possibly caused by uneven layering or rotation. But a few anomalies persist. Loeb and his colleagues argue that the physics behind such motion should be investigated without bias, not because it implies artificial design, but because understanding unexpected forces can expose new natural processes. NASA and the European Space Agency have reiterated that the available data show no evidence of anything other than a natural comet. Still, they agree that its behavior warrants extended observation. This measured approach contrasts with the divided public reaction following the discovery of Oumuamua in 2017, when limited data allowed speculation to outpace evidence. What makes this event different is the level of coordination. More than a dozen research institutions are sharing real-time observations through the International Asteroid Warning Network. The campaign involves professional and amateur astronomers alike, aiming to collect data across multiple wavelengths, visible, infrared, and radio, to map gas emissions, dust density, and compositional shifts as the comet cools. Already, preliminary data hint that the object's composition may evolve as it moves away from the sun, possibly developing a faint ion tail. If confirmed, that would mark the first time such behavior has been recorded in an interstellar comet with this level of precision. Each dataset brings scientists closer to determining whether comets like 3I Atlas are common messengers from other star systems or rare fragments ejected under exceptional conditions.
I have something to add to your New Yorkistan name. Stand by.
The events surrounding 3I Atlas show how space science and public policy increasingly intersect. Congressional interest in a single comet would once have seemed unlikely, yet the growing conversation about transparency in space data has made such oversight inevitable. Representative Luna's involvement underscores a new political awareness that discoveries beyond Earth have both scientific and cultural resonance. NASA has stated that all data collected during the shutdown will be publicly released once normal operations resume. The briefing with lawmakers is expected to outline how such interstellar detections fit into long-term strategies for planetary defense and scientific collaboration. At the same time, the Pentagon's All-Domain Anomaly Resolution Office, responsible for analyzing unidentified aerial or space phenomena, issued a brief clarification. 3I Atlas is fully identified and poses no security concerns. The mention was procedural, but it highlights the structured communication now used to prevent confusion between scientific events and speculative narratives. Internationally, the observation campaign now underway is being coordinated through the European Space Agency and the Lowell Observatory in Arizona. The goal is to continue tracking 3I Atlas until it becomes too faint to detect, using instruments across both hemispheres to build a continuous timeline of its evolution. Data will include measurements of its polarization, a property that reveals particle size and structure in the dust cloud, helping scientists estimate how the comet formed. The broader community is already looking ahead to the next generation of surveys. When the Vera C. Rubin Observatory begins full operations, it will scan the entire sky every few nights with sensitivity high enough to detect many more interstellar visitors. Astronomers expect that events like 3I Atlas could become annual, rather than once-in-a-decade phenomena. That shift would transform these fleeting encounters into a new research field. comparative studies of interstellar comets. Each future discovery will add statistical weight to models of galactic dynamics, showing how fragments are ejected from planetary systems and how often they pass near stars like ours. For now, 3I Atlas continues on its outbound path, faint but still measurable. Within months, it will slip beyond the reach of most telescopes, leaving behind terabytes of data and a clearer picture of how the Milky Way's systems exchange matter across vast cosmic distances. E3I Atlas is fading from view, but the data it leaves behind will shape how we study interstellar visitors for years to come. It has connected scientists, lawmakers, and observatories in a rare global effort of discovery. Another reminder that even across light years, our solar system is never truly alone.
Let's do it. You asked, here it
Are you
is.
paying attention at all to 3I Atlas? Are you watching
Oh, there's
that?
the comet?
Yeah, whatever it is.
Yeah. I mean, one thing I can say is like, look, if I was aware of any evidence of aliens, Joe, you have my word. I will come on your show, and I will reveal it on the show.
Okay.
Yeah.
That's a good deal.
Yeah, it's a pretty good.
I
deal.
believe you. Yeah, thank you. Appreciate that.
I'll stick. I keep my promises. So,
all right.
yeah,
I'll hold you to that.
Yeah,
Yeah,
and I'm never committing suicide. To be clear.
I don't think you would either.
Also, on camera, guys, I am never committing suicide. Ever.
If someone says you committed suicide, I will fight tooth and nail.
Thank you.
I will fight tooth and
Thank
nail.
you.
I will
Thanks,
not
brother.
believe it. I will not believe it. The thing about the 3I Atlas is it's
That's a hell of a
weird.
name, actually.
Yeah, it's a third.
It sounds like
interstellar.
Third Eye or something. you know?
Yeah, it does. 3I is third. It's only the third interstellar object that's detected.
Okay.
Yeah, Avi Loeb.
Third Eye Atlas.
Yeah, Avi Loeb was on the podcast a couple days ago talking about it.
Yeah.
And,
it could be aliens. I don't know. But
Apparently today they're saying that it's changed course. Did you see that, Jamie?
Thanks, Jim.
Avi Loeb said something today. I'll send it to you.
I still say it is Gorf Alf's brother coming to see the weird aliens on Earth, especially in Portland. Yeah, he's coming from Melmac, right? Hey, Steven, thank you so much. Aliens don't come to Earth to be indoctrinated, right? Now they're gonna, and then now they, instead of chanting for Palestine or the free this and do that, now they're gonna chant for like to free the green aliens, you know?
I know it's on Reddit. Here you go, Jamie. I'll send it to you right now. It's fascinating. It's fascinating also
Hey guys, alien lives matter. You know what I mean?
because it's made almost entirely of nickel, whatever it is. And
Yeah.
the only way that exists here is industrial alloys, apparently.
There are definitely comets and asteroids that are made primarily of nickel. In fact,
really?
Yeah. So the places where you mine nickel on Earth is actually where there was an asteroid or comet that hit Earth that was a nickel-rich.
Wow, and it
nickel-rich
left a giant
meteorite.
nickel-rich deposit?
Yeah, that's it's coming. Those are from impacts. So you definitely didn't want to be there at the time because anything would have been obliterated.
Right.
But that's where the sources of nickel and cobalt are these days.
So this is Avi Loeb. A few hours ago, the first hint of non-gravitational acceleration, that something other than gravity is affecting its acceleration, meaning something is affecting its trajectory beyond gravity, was indicated. Interesting. Dun, dun, dun. So it's mostly nickel, very little iron, which he was saying is on Earth, it only exists in alloys. But whatever, you're dealing with another planet.
There are cases where there's very nickel-rich asteroids, meteorites that
And that's
have
what it
that
is,
have
for
hit
something
Earth.
from space.
Yeah, it's only
Yeah.
It doesn't mean it'll be a very sort of heavy spaceship if you make it all out of nickel.
Oh, yeah. And
So-
fucking huge. The size of Manhattan and all nickel. That's kind of nuts.
Yeah, that's a heavy spaceship.
That's a real problem if it hits.
Yes. No, it would like obliterate a continent type of thing.
Yeah.
Maybe worse.
Yeah, probably kill most of human life, if not all of us.
I haven't looked. It depends on what the total mass is, but there's. I mean, the thing is, that, like in the fossil
Pay
record,
attention.
there are, there's like arguably 5 major extinction events. Like the biggest one of which is the Permian extinction, where almost all life was eliminated. That actually occurred over several million years. There's the Jurassic. I think that one's pretty definitively an asteroid. But there's been 5 major extinction events. But what they don't count are really the ones that merely take out a continent. So
Merely.
yeah, because those don't really show up on the fossil record, you know.
Right.
So unless it's enough to cause a mass extinction event throughout Earth, it doesn't show up on in a fossil record that's 200 million years old.
Cold Media, what's up, bro?
So but there've been many impacts that would have sort of destroyed all life on let's say half of North America or something like that. There are many such impacts through the course of history.
Yeah, and there's nothing we can do about it right now.
Yeah, there was one that one that hit Siberia and destroyed, I think, a few hundred square miles.
Oh, that's the Tunguska.
Yeah, exactly.
That's the one from the 1920s, right?
Yeah.
Yeah, that's the one that coincides with that meteor, that comet storm that we go through every June and every November that they think is responsible for that Younger Dryas impact. Yeah. All that shit's crazy.
Close eye on 3I Atlas, a Manhattan-sized interstellar object believed to be a comet getting closer and closer to Earth. Take a look.
Okay, hold on. This is from 10 hours ago, Colleen. Everybody else, thank you for joining me. Hey, I had 1,000 viewers. That's pretty dope. Give the stream a thumbs up. Subscribe to my channel. If you're not, I am not a space channel, as you'll see. But I think space is cool. I think this is pretty interesting. And I was bored. So thanks for hanging out. I appreciate it.
Look at the new images of the object appearing to have lost its tail. Some scientists now theorizing that this is a new indicator that 3I Atlas is no comet, but potentially an alien craft. Well, just under 6 weeks from now, it's set to get close to our planet, relatively speaking. And as several scramble for more answers, theoretical physicist and Harvard professor Avi Loeb called on NASA to release its new images of 3I Atlas. He shared this with us last week.
The best image was taken on October 2nd by the HiRISE camera on board the Mars Reconnaissance Orbiter. And unfortunately, the argument is because of the government shutdown, this data was never released. It doesn't make much sense for the politics of the day to sabotage the progress of science.
So what does this mean for all of us here on Earth? To help get some answers and some perspective, we are joined by world-renowned physicist Dr. Michio Kaku. He's co-founder of the string field theory, author of Quantum Supremacy, How the Quantum Computer Revolution Will Change Everything. Dr. Kaku, always a pleasure to see you. Thank you so much for being here. And let's jump right into this. I want to start with the new images of 3I Atlas, not from our own NASA. We are still waiting on those. These ones are out of Spain. Some are noting it looks like this object has lost its tail after passing the sun. What's your take here? And if there's no tail, does that mean this is indeed not a comet?
Well, I have my own point of view on this, and that is that this is a very old object, perhaps 7 billion years old. And in 7 billion years, there's been plenty of time to accumulate garbage. That's why, for example, the nickel content of the comet is off scale. Its chemical composition is not what an ordinary comet should be. And that, I think, is because over 7 billion years, it's had plenty of time to accumulate different gases, different elements, different kinds of environments that it goes into. And I think that explains a lot of the mystery behind the comet. and everyone's talking about it. I was on the airplane the other day and overheard some people talking over my shoulder, and sure enough, they were talking about the comet too.
Did you pop your head over the seat and say, "Hi, I'm Dr. Michio Kaku, one of the foremost experts on this, and this is my opinion"?
No, I did not say that. But
Why
I
would he say
gladly have
that?
given them my opinion.
Yeah.
It's a 7 billion-year-old comet, and that's why it's different. It's different from other comets. Comets in our solar system, for example, are maybe only 3 to 4 billion years old. This one is a very old comet, and as a consequence, it has plenty of time to accumulate garbage, and that's one of the characteristics of this comet. It has nickel, iron content, which is
Only that he's like
different from the
Japanese.
average comet.
You know, we're still waiting on an updated image of this object from NASA. We see
Yeah, he looks like Richard if Richard was a Japanese world-renowned astrophysicist.
Representative Anna Paulina Luna sharing this week that it will not be shared until the government is reopened. Do you
Where's
make anything
Tommy?
of this? Is NASA hiding something here?
Tommy probably sleeping.
Sounds like it, right? I mean, what do they got
Or getting
to
breakfast.
lose? I mean, it's only a sheet of paper. I mean, it's not like a top secret thing you put in a safe. It's just a sheet of paper. So what do they got to lose by announcing that they have this information? Because it fosters more and more speculation. And at a certain point, it becomes counterproductive.
You've been closely monitoring 3i Atlas for months now. I'm tracking these anomalies, some bizarre behavior. What are the odds that we're dealing with something not just old, but something that's extraterrestrial in nature?
She's digging for it.
I think it's non-zero, but it's very small.
She wants it so bad.
So far, it looks like an ordinary comet. It behaves like an ordinary comet. And except for these, a few
Oh, yeah.
anomalies,
That's exactly. Rocco is absolutely right. Tommy is currently with Jesus. We're not going to interrupt Tommy. He's with the Lord.
It does act like an ordinary comet. And so I think it's really pointless to preserve secrets to keep things away from the American public. The public want to know.
Avi Loeb, meanwhile, out of Harvard, believes that 3i Atlas may be revving its engine. Any thoughts on that?
Well, there's a possibility. You have to put probabilities with regards to all the speculation. Avi Loeb was very careful later on to say that the probability of his speculations are quite low. And so we have to put this into perspective that these are guesses, and as a consequence, they're not 100%.
3i Atlas has been added to the International Asteroid Warning Network to prepare Earth for a potential threat from beyond. We understand the object is going to get as close as 167 million miles away from Earth by December 19th. That is just weeks from now. Is there any reason for us to be concerned?
Personally, I don't think so. I think it's quite a distance away. We're not going to be invaded by aliens from a Hollywood movie set. So I think that it's harmless. It's so far away that we're not going to be endangered.
I'll be right back.
Professor Avi Loeb has really been out in
I got
front of
5
all
minutes.
of
I'll be
this,
right back.
theorizing this could be extraterrestrial in nature. Perhaps this is a craft coming, doing some reconnaissance, just coming to check us out. What is your message to him? What do you have to say about his theories?
Well, speculation is fine, but you have to quantify it. You have to say that what is the level of confidence on the speculation? Is it 100%? Is it 1%? Otherwise, you panic the public, and the public wants to know the truth. Because afterwards, if it turns out it was a false alarm, then there's going to be a public backlash. People are going to say, what? We wasted all our efforts and there was no danger at all. So I think when you mention the dangers, you have to quantify it to say how realistic is this estimate.
I know that you warned if 3i Atlas picks up extra energy as it whips around the sun, that would mean in no uncertain terms that some intelligence is guiding it. Is there any indication some intelligence may be guiding this?
So far, no. However, there's been some speculation that it seems to be speeding up a little bit as it goes around the sun.
That's,
But remember,
that's kind of concerning. I mean, the quote was that that intelligence would be there if it sped up around the sun, no? And it did.
to a slight degree, right?
She wants him to say there's aliens so bad. She's got a shovel and she's been digging for like 5 minutes. She's begging him to say it's aliens, all right? God, Jesus, woman.
And however, there are reasons why it could happen. For example, maybe the comet broke a piece of it off. Maybe there was outgassing of the comet. There could be reasons that explain why there's a sudden spurt in velocity. So that's not a smoking gun. That doesn't nail it to the wall. It's just one condition that we would use to guide us into thinking that perhaps there's intelligent life there, but it's not definitive.
Yeah, what is the next thing that you are watching out for most closely then? What would be the smoking gun, nail it to the wall, other than, of course, it just landing? And like you said, some creatures crawling out from a Hollywood set.
Yeah, well, I think if E.T. phones home, that would clinch it right there.
Is there anything more scientific than that you'll be watching out for next in its trajectory?
Well, if they try to communicate with us, some kind of Morse code, some kind of language that we would understand, some mathematical language, for example, that would clinch it. Rather than getting static on a radio, getting an alien civilization share their knowledge with us, that would nail it to the wall.
Yeah, one more question on this before we move to AI, because I understand there is a deep fake that you've been battling recently, and I want to hear more about that. Tell us what we need to know about this. It seems like there is a lot of speculation. It sounds like your message to the public is that they shouldn't be too concerned about this.
Well, you can just Google it. When you Google the name of the comet, there I am.
Shit. I understand, Jessica, that he got arrested on camera. There's like pictures and stuff of him being arrested. I saw it.
I'm on several networks talking nonsense.
Yeah, I know I was muted. You
Realize
don't have
that
to tell
it's very
me.
easy to forge these documents.
Oh, so we're talking about deep
Right.
fakes now. Okay, so let's talk about this, Dr. Kaku. You yourself have been putting out warnings because deep fakes are happening of you. I believe that we might have some of them to show, impersonating you,
deepfakes.
AI generating this, misleading the public with false claims. And you say it's not just deep fakes that are out there right now. Countries are racing towards quantum computers, and that is the real risk going forward. Can you tell me more about that?
Yeah, it turns out that the PC that you have in front of you is digital. It computes with zeros and ones. Quantum computers are way ahead of that. They compute with any number between 0 and 1. And how many numbers are there between 0 and 1? Infinite number. And so we see the power of a quantum computer that can break into any known digital computer. So who's worried about this? The CIA, the FBI, all intelligence agencies are on the alert. Because when it happens 5, 10, 15 years from now, watch out.
Yeah, Dr. Kaku, does that mean that this could break into nuclear codes?
In principle, yes. Anything that is digital can be broken because digital codes work with zeros and ones, while quantum computers work with everything in between 0 and 1. And how many numbers are there between 0 and 1?
You're telling me infinite.
That's
Dr.
right.
Michio Kaku, I always appreciate you so much. This is a fascinating topic. I'm being told we're out of
Jesus,
time, but
dude.
thank you so much. Have a great evening.
I don't have enough breadcrumbs to get back home after listening to her. You know what I mean? For fuck's sake. Dude. Okay. All right. 2 more videos. No, 1 more video. Okay. So if you don't know who this guy is, I'm going to hold on a second. I'm going to make sure something else first. Stand by. Hold on. Give me a second. Stand by. I'm going to give you this guy's link so he doesn't get mad. I don't think he would. Where are we at here? We are Stephen Burns. Okay, here we go.
Hey everyone, welcome to the live stream.
Hold on. Copy. Okay, all right. This guy is awesome. I watch this guy all the time. He's a streamer. Okay, his name is Steven Burns. He's an astrophysicist. I mean, he made 3i Atlas shirts. This guy does run a channel that is, you know, all about space. So if you're down for that sort of thing, hey, share the love, man. Go give him a sub and a like on the video. But yeah, this guy knows. He's got so many, seriously, so many videos about this subject that if you've been doing research on it, you probably already know who he is. So, anyways, this is a 40-minute long thing. We're gonna watch the whole thing. Why not?
Stellar object.
He's awesome.
It
Go give him a like.
Begun erupting jets of plasma. So now it has either multiple tails or...
Oh, last thing is, this was done... Let's see here. This was done 23 hours ago. 23 hours
and
ago.
or multiple jets of gas, dust, and plasma being emitted from it. This is based off of a brand new observation made today, November 8th, early in the morning. That's when you observe 3i Atlas right now, because it just is perihelion with the sun. So it's very close to the sun. It's in the night sky just before sunrise, and then the sun rises and they all move up like this, and now it becomes too bright to see 3i Atlas during the day. So it was observed by Michael Yeager with either multiple tails and or jets of plasma, and this tells us quite a few things. In addition to that, as I reported just a couple days ago, C2025 V1 Borisov, the new comet that was picked up just about like November 2nd, November 3rd, somewhere in there, that was situated directly in between 3i Atlas and the Earth, it appears to have disintegrated. So it's basically disappeared. It was only observed for a few days before poof, it's gone. So very bizarre that it was found in between 3i Atlas and Earth.
This guy is an actual No. This guy's an actual, like, I want to say journalist, but he's an actual, like, astrophysicist and, like, very knowledgeable about this. He is not a flat earther. He doesn't have any weirdo, crazy takes. He actually gives you mostly facts, you know, not a lot of opinion pieces. I like this guy a lot. He's got 582,000 subscribers. He's doing something right. You know what I mean?
Earth, its orbital trajectory was calculated to be quite a bit different and not headed to Earth. This is the orbital trajectory of Borisov that was calculated for it to go up, its perihelion being on the 8th of November, which is today.
Yeah, Bonnie, you tell him. You tell him. Bonnie knows. She watches this guy a lot, I'm sure.
And well, on perihelion, poof, it's gone. 3i Atlas, meanwhile, did perihelion on the 29th of October. And now, after being hit with all this solar wind and radiation and solar storm impacts, it seems to finally have awakened and begun its final activation, where now it's spewing out jets and tails and everything. So it's not just one tail, and it's certainly not a super epic, magnificent tail like A6 Lemon, the comet that has its perihelion also today, November 8th. Actually, Borisov, sorry, its perihelion was calculated to be like I think it was like the 16th of November. It's A6 Lemon that has this perihelion today. But 3i Atlas is finally now producing some sort of tail. So that's what we're going to talk about in today's video. We'll do a Q&A and more. Hello and welcome. I'm your host, Stefan Burns, geophysicist, geologist, space weather guy, cosmic bro, whatever. I'm here to track what is happening energetically on Earth in our solar system. So we look at everything: earthquakes, volcanic activity. We also examine solar activity, space weather. We're in solar maximum right now. One reason why there's been so much energy being broadcast out is because the sun is in the middle of its magnetic flip. This happens once every 11 to 12 years. And quite coincidentally, it launched a ton of solar storms towards 3i Atlas. We were forecasting that back in July. It did happen starting October 21st. We'll look at that imagery. And then we also examine comets and interstellar forces and more. So if you like the sound of that, then please subscribe. Hello and welcome. Happy Saturday. Okay, so let's look right at this imagery right off the get-go. Here we have our latest imagery of 3i Atlas as provided by Michael Yeager. This is linked in the video description. He posted this on Twitter. So if you want to check this out yourself, you can. Originally, I was going to apply some image correction to this, like make it pop out a little bit more, but I decided not to. I decided just to post exactly as he did. So he posted 2 different versions. This one has had some image correction done to it to make it pop a bit more. We see the solar direction, okay? So sun is over here, and 3i Atlas is going like this, okay? It's going like that, and we see not 1, not 2, but 5, at least this is what Jaeger identified, 5 different jets coming off of it. One tiny one right there, very faint one right there, but these 3 are more obvious. 1, 2, 3. So that's quite striking. You also see it on this imagery. And here, in some aspects, it's even easier to see. That forward jet, you definitely see that nicely. Here we see that top one. And then this one, I mean, even maybe you can split it kind of into a fractal dendritic nature going like this. This is the coma. It's not the nucleus. We're not going to be able to see the nucleus, the actual object or whatever this thing is, until you can get close enough to kind of pierce through that coma, because it will absorb a lot of light. And so it's just, we're going to see that diffuse cloud of gas and plasma more. But we're not going to see the coma itself. We don't really know the size. So we're going to talk about 3i Atlas, and also I'm going to muse a little bit about just kind of, you know, consciousness and more as it relates to this thing, because I don't think it's aliens. I also think it's not just some inert space rock or comet. I think there's a lot more to the universe than mainstream science has, you know, taught a lot of people, and that there is a lot of consciousness with this thing. And now it seems to be activating, because we've been watching it, talk about it, and saying, hey, there's no tail, there's no activity, it got hit with all these solar storms, like,
I don't
what's
like that word
happening? I
activating.
mean, it got hit with a ton of solar energy. The solar wind, the light radiation, and all these like solar storms, which some of which are all combined together. It's like one of the most active periods of solar activity in decades. Didn't seem to do anything, because we also do have imagery of 3i Atlas from its pre-perihelion stage. This is taken by the CCOR1 coronagraph. We have stacked images here. Then we also have stereo A stacked images, and this goes back to September, going through October, and this is October 18th to 24th, highest resolution. You don't really see a tail on this thing. I mean, you see definitely a coma and maybe a little bit more pushed out there. At this time, that's the sunward direction. Now, you also have to keep in mind that there is a tail. It's going to be in front of 3i Atlas like this, because we're looking at it effectively head on. Well, sorry, it's going to be behind 3i Atlas because the sun is in front, and so it would stretch out directly behind it. So that makes it hard to see the tail. But, you know, it's definitely some sort of shapeshifter in terms of what it's doing. It's not consistent in its behavior, which is quite bizarre. I think that's one reason why so many people find 3i Atlas so fascinating. So if we go back here, we see these different jets, and we're going to talk about the plasma environment a little bit of comets too, because there is a very rich energetic environment around comets, or just any sort of object that is off-gassing. That's the key. And this latest data...
Jessica, why? You ain't going there. Does North Korea scare you? Why? You gonna go to North Korea?
is suggesting that 3i Atlas is more porous than we perhaps originally thought, and maybe it's finally receiving some deep heating from the sun. Like maybe it took a little bit of time, but that deep heating is occurring now. That's causing volatilization of gas, which then transports dust with it as well, because it's hypersonic. It's moving at extreme speeds to then form this coma, which then, as it starts to interact with solar radiation, which is photoionization, a light photon hits a particle and splits off the electron. We have that happen here on Earth, other planets everywhere, right? This is just physics. And then also you have charge ionization due to the solar wind, and you also just have general ionization due to free electrons that are already bouncing around that are highly energized, that then also create new additional ions through interactions. So the moment this gas and dust expands out into the coma, it starts to ionize. You get this shock region here on the very close inside. Behind the comet is this neutral sheet, so that's neutral gas that does not have a charge. So it's not really interacting with the electromagnetic field. but you do have some cross-tail currents, some complex electromagnetic currents and kind of forces at play in the tail. This is anti-sunward. One of the weird things about 3i Atlas is that originally it was pushing out towards the sun with its coma. It had a sunward facing tail, which is quite bizarre. Then you have this ionopause. Then you have a commutopause where the magnetic field can get very, very strong. This magnetic barrier, typically around 50 nanotesla. Here it's labeled as gamma. That's the equivalent. So 50 nanotesla. But what we picked up with other comets before, specifically the ESA mission Rosetta, was orbiting around a comet for a while back in 2014. I think it was 2015, 2016, that zone right there. They noticed a solar storm impact with that comet, and the commutopause magnetic field went up to 300 nanotesla. Now, that was one solar storm impact. 3i Atlas received many solar storm impacts and big ones. So we don't know how strong that magnetic field surrounding it got, but it definitely supercharged up. We just don't have direct in situ measurements because we just weren't fast enough to get a probe launched to 3i Atlas or to commandeer one of our other probes, Maven or Juno. Juno is out near Jupiter, so that would be later on. But then you have the solar wind, you have the bow shock here, strong plasma waves can exist in this area. And you also have all the dust, the heavy dust of the comet or whatever this thing is, getting ionized as well, causing the overall solar wind to start to slow down and drag. Because it's very, very fast, especially a coronal mass ejection, 800 kilometers per second, 1,000 kilometers per second. Whereas this volatilizing out slows down pretty rapidly, especially once it ionizes and now is trapped in certain regimes under electromagnetic fields. Like for example, magnetic field will hold an ion in sometimes very specific areas. Example again, the ionopause, the commutopause, the bow shock here. Now because 3i Atlas seems to be volatilizing based off of this data, it's effectively spewing interstellar material all over our inner solar system. And here's the deal, we don't know where this thing is from. Whether it's from maybe a nearby star system. I talked a little bit before one of my videos about how it's really not that far off from Barnard's star, which is effectively also in Sagittarius, so it's a little bit above the ecliptic plane. 3i Atlas came in at 5 degrees, but traveling at the speed that it was originally, 58 kilometers per second or so, and Barnard's star being about 6 light years away, that's a travel time of 30,000 years. So it actually wouldn't take that long to come in from Barnard's star, but it could also be from a completely different galaxy.
Yes, Rob.
We're talking about interstellar, intergalactic, universal time now. So it could have been traveling through the universal medium for 1 billion years, 2 billion years. We don't know how old this thing is. Now, Earth is, we think 4.54 billion years old. The sun, all this, it all formed roughly 4.5 billion years ago. That's our estimate based off of radiocarbon dating, okay? So, our system is old too. But the longer something's traveling just through, the universal medium, the more it's preserving those original characteristics that it had. Now, there is cosmic rays hitting it, but overall the flux rate's quite low. When it's out in the void of space, it's not changing that much. It's receiving a huge amount of energy now that's coming into our inner solar system, being heated up by our sun. So now it's spewing out this interstellar material, and we don't know what that's going to do for us here on Earth, for the rest of the solar system, the sun. It's very bizarre. We have quite a lot of observational evidence. For example, the best example I can give you is ice crystals and how water stores energy and information. The quantum dynamic properties of water. Water can form what are known as coherency domains. And so they are able to enter in these specific resonances. The different molecules in the hydrogen bonds can enter into these specific resonances and capture light photons even at wavelengths that are very low that they normally shouldn't be able to do. It's like Schumann resonance. And therefore, they're also able to capture and hold on to information. There's a lot of amazing work out there that's been done by a variety of people showing how water will hold on to energy and information. You water the plant, that water is charged up with good energy. The plant triples in growth, and then the water that you tell it you hate, the plant basically dies. So there's these sort of experiments. There's also these flash freezing ice crystal experiments where you put a petri dish of ice over like a photo and you flash freeze it, and you'll see that photo represented in the crystal structure of the ice. Some people are even putting thoughts and intention into these petri dishes and seeing those things that they're visualizing in their mind appear in the ice. So water is absolutely crazy. It's super quantum.
What?
It is a portal into everything. We are made up of a ton of water.
I must have heard
That's
that
just one
wrong.
example of how a material or mass can hold on to unique energy and information. This thing's now spewing out a ton of this extragalactic material and energy into space, and it's going to spread out across the entire solar system because the solar wind is going to sweep it out. So that's like, we don't know the effect of that in terms of
David,
consciousness
it's called science.
here on Earth,
Oh, I've never
or
heard
maybe
of it.
the entire consciousness of our solar system, one integrated unit, the sun, the planets, the asteroids, the comets, TNOs, and more. We have also the fact that Borisov has disintegrated. This is our first image right there. Then we see two more, and we see effectively it has disappeared. So it originally came in, it was, some people were even mistaking it for 3i Atlas because it looked very similar, did not have a tail as far as we could tell. And it was also situated in such a way that we should have been able to tell whether it has a tail or not. I'll talk about that 3i Atlas next. But in the span of just a few days after detection, it has disappeared. And what was so interesting about Borisov is that it was picked up in between Earth and 3i Atlas. So that's the weird thing. We had its calculated trajectory based off of the measurements and observations of the astronomers showing it going like this. But at the time of observation, right, this is all calculated. That's all calculated. At the time of observation, we basically picked it up directly in between 3i Atlas and Earth. We saw it for a few days and then poof, it's gone. So that's pretty bizarre. Whether that actually was just, hey, it actually did come from in here, and then as it got close to its perihelion in mid-November, it did disintegrate, right? That's one explanation. The other one's a little bit more bizarre and calls into question a lot of things as it relates to the next few weeks on Earth. Because all of a sudden we get this thing popping up, it doesn't have a tail, and then it just poof, it's gone. Very bizarre. Now 3i Atlas, I want to show you the arrangement here, because it's difficult to see these jets or this tail, whatever these things are, from the angle that we're at. So this is a pretty incomplete view of what we're looking at. So here we see the Earth, and we see 3i Atlas, and we see the sun, okay? You'll notice that this is still pretty much behind the sun. It's not perfect. We are seeing it now slightly at an angle, but in general, it's not a big deviation from 180 degrees like it was back on the 21st. If you go back to the 21st of October, let's do that, just really 8th, we see that we're still pretty much aligned with that. So it's only going to be slightly at an angle as viewed from Earth like this, right? A lot of it is going to be skewed behind 3i Atlas. So if you keep that in mind, we're just seeing that skewed angle. It's not exactly perfectly lateral to or perpendicular to our viewing angle. It's actually going out like this. And this also shows that nicely. So in the coming days and coming weeks and even months, we may find that 3i Atlas is actually more energetic than we originally thought it was going to be, and that it has a bigger tail than perhaps we thought it was going to have. Because we also have our database of apparent magnitude measurements for 3i Atlas, and we can see that right here. It's been a lot brighter than expected. So let me pull this up. Here we have our COBS data, and this shows the light curve of 3i Atlas. It was following effectively the light curve, dipped a little bit below it here September, went above it starting October. We have measurements of the light from 3i Atlas with CCOR1 and C3 and punch data from NASA. NASA has not yet released its high-rise imagery of 3i Atlas, but it's probably not going to be that great anyways, but they're not doing it. Here's our latest astronomical measurements of 3i Atlas from a variety of groups, okay? And we see that that is coming in at 9.4 and 9.4, 9.8. You know, the model is expecting it to be 11. It at 9.4, it's nearly, that'd be like nearly 5 times brighter because each jump, one jump is 2.54 increase. So it's quite a bit brighter than expected. And that's one reason why I've been like, hey, where's that tail? Where's the tail? Like, it's very bizarre that it's much brighter than expected, but doesn't have an apparent tail. Now we're starting to see something, but it's actually not just one tail. Again, it's jets, like multiple. Like this is, you can more accurately describe this, in my opinion, as jets than a tail, because you have 1, 2, 3, 4, 5, perhaps more. Here we see our CCOR1 imagery from the 21st through early November for 3 Atlas's Superior conjunction through perihelion. That was the first big solar storm that launched out. 3 Atlas is tracking right about here at this moment in time. You only pick up in a few frames. There's another solar storm. This is all launched to the far side of the sun, okay? So this is not Earth directed. 3 Atlas was on the far side. There's another solar storm. I mean, just watch this going all the way through from its exact alignment, Earth, Sun, 3 Atlas through its perihelion, its closest approach to the sun, which was not exactly behind the sun's view from Earth, but pretty close. We see a ton of solar storms launch out to the far side. All of these are far side events because of the big sunspots, which are now Earth facing. In fact, the biggest one is in the Earth strike zone right now. So it's really quite striking. And this is going, as you can see, there's a few periods, like a day or two, where you don't really get much from the sun. You get some activity, but not like that first big one. We'll look at that one more time when we get to it. But we see it kind of resume again with the perihelion. There's some more activity. And so if we, I think it's getting close to the end here. Yeah. So we saw that 3 Atlas was here at the beginning, and then it moved across like this to the end. So at the very beginning of this video, it got some flank impacts from the side because they were mostly directed this way. The sunspots were rotating across the far side like that. Then it swung through as the sunspots rotated like this, and they kind of traded places, you could say. So here again, 3 Atlas is going to be right in here. And then we're going to see this big first explosion. See, it's more of a flank impact. And then as it goes through the 24th, it's going to be basically right here. And then it's going to continue on. Well, actually, the 21st is going to be right there. Let me go back in time. The 21st was the Superior conjunction exactly. It was exactly in line on the 21st. Back on the 18th and 19th and 20th is when it was showing up here. Right there, 3 Atlas is like in this zone. And then it transited off by the 24th.
That's funny,
so you
Rocco.
see, again, all these things launching out effectively in the direction of 3I Atlas during this time frame. So that's one reason why it is energized so much. And now we're seeing this activity from 3I Atlas with these jets. And if we look at our model here, we can understand a little bit more of the plasma dynamics as I talked about. Keep in mind, there's some differences between a comet or like some small object or something like this and a planet. Because you could say, well, you know, why don't we get, you know, special effects like...
Hey, Jessica, there's going to be a test. I'm just going to give you a blank one of these, and you're going to have to label it. You ready? I'll give you a word bank. You could just draw a line across. You know what I mean? You'll be fine. You'll be fine.
Like, how is it that a comet can do anything? It's too small. That's the whole reason why it can affect perhaps solar activity and affect the energetics of the solar system, is because it has such a low gravitational field. If it has all these highly volatile minerals and materials like CO2, CO, CN, water, those are the main elements and molecules that are picked up by spectroscopic imaging of 3I Atlas. If it has a lot of those, they will volatilize, and that rapid hypersonic transition from ice to gas will then carry with it a bunch of dust grains, and then they'll explode off the surface like this, and gravity won't hold them in place. Gravity is not going to pull them back down. On Earth has enough mass and size, it can hold on to its atmosphere. Venus has a super thick atmosphere. It can hold on to it. Mercury's smaller, Moon's smaller. They don't really have atmospheres, right? The moment you start to get smaller, like dwarf planet Ceres or Pluto, you start to lose that atmosphere. Mars has atmospheres fairly thin, but it's a bit bigger than those. But, you know, of course, Jupiter, mostly atmosphere. Saturn, mostly atmosphere. Uranus, Neptune, right? So as you get big...
You ever watch Star Trek? You notice something on Star Trek? Not only do they never go to the bathroom, they don't have bathrooms. You want to know why? You want to know why? Beaming technology. I'll let you think about that for a little while.
Bigger, the more you can hold on to these gases that want to fly away and resist the force of gravity because they're so light. You need a bigger gravitational field to hold on to them. This thing has almost no gravity. So if you can get those ices and materials to volatilize, now all of a sudden you just have this expanding out, basically.
Check it, prove me wrong. Not one Star Trek show or Star Wars, for that matter, has bathrooms. What the fuck is going on? What is that?
With gravity having almost no effect on it to pull it back down. That's how it then ionizes, and then you can get this exchange of energy and perhaps, with energy information between these sort of objects, comets, whatever, and let's say the sun.
Yeah, they have replicators in Star Trek that you just go bacon and cheese sandwich and a Dr. Pepper, and it goes and it makes it. So yeah, they eat all the time. They have big feasts and stuff. And like some of it's alien cuisine, so you would think they would need a toilet. You know what I mean?
Because you can have this actually push out when it gets pushed in by a big solar storm impact. That ionization actually causes it to push out more because there is this fact that now it's expanding with under electromagnetic forces. Again, gravity is not really holding it back. And then it can start to disperse and spread out in the solar wind. So it's really quite striking. So that is what's happening with 3i Atlas at this moment in time. It's much brighter than expected. It has now started spewing out multiple jets, and these could be tails, jets, we don't know, but there's some sort of dispersal of interstellar or extragalactic or whatever material just from a completely different system of unknown origin and unknown quality now being spread out in our inner solar system. And that's going to continue for a while because it's still close to the sun. We'll go back to our Sky Live. Here it is today again, right? It's still well within the orbit of Mars.
We're almost done, guys.
It's going to take a while before it reaches Jupiter here. It's going to do a close flyby of Jupiter. That'll be interesting. That's mid-March. But we have quite a ways before it leaves the orbit of Mars. Let's actually check that out. It leaves the orbit of Mars roughly on the 23rd of November. And then it actually has its closest approach to Earth on the 19th of December. So this entire time zone right there is very dynamic, and there are other forces besides the solar wind that just push out. There's also inward flowing electric currents in our solar system that run along the ecliptic plane that could feasibly also pull things in because it's inward flowing electric current, radial like this going.
Hey, Bonnie says, I would like to see the bathroom and the bar in Star Wars. I would not like to see the bathroom in the bar in Star Wars. That's nasty. We got one more video after this, and then we'll be done. Then I'm going to get ready. I'm going to have some lunch. I'm going to, do the dishes and laundry and get ready for tomorrow. And then I'm going to prepare my stream for the Portland craziness. And then I'll be back later on this evening, right? So about maybe like 30 more minutes or a few more minutes. Yeah.
Going to the sun. So it's not just the solar wind going out. You also have this reciprocal force coming in. And perhaps that's going to carry some of these volatiles and dust and plasma from 3i Atlas closer in to our inner solar system. Then it starts to interact with the planets. How does that affect things? We don't know. I'll keep you up to date with that as best I can as we learn more. But those are some of the big findings right now. And
we've got a big update, a huge update on our favorite interstellar object. It could be the biggest update in the solar system. Take a look at this. This is 3i.
Okay, guys, this is going to be the last video, right? It's later on. Vicolin. Oh, that's a cool name, Vicolin. It's going to be later on, like 6 p.m. Portland time, 5:30 Portland time. Jessica, what do you think? You're in Portland, right? Or you're in Oregon? About 6 o'clock it pops off. Tommy goes out there, so I'll be live then. About 8 o'clock my time. I'm in Texas, so this will be the last one, right? So this, it says notorious Chinese scientist just made contact with 3i Atlas, and it's a warning. This video was posted 20 minutes ago. So we were live when this went live, okay?
Atlas. You know how the last time we talked about it, it went behind the sun, then it got brighter, then it got bluer, then it started to go faster, non-gravitational acceleration? Well, guess what? We just got new images of it, and to add some more strangeness to the 3i Atlas saga, because, like, I don't want to overhype this, but yeah, you see, that's a comet. It does not have...
A rogue Chinese physicist just made contact with something drifting through our solar system, 3I/ATLAS. An interstellar object with signals that defy every known law. His unauthorized experiment triggered a response. Now, it's coming closer. This isn't science fiction, it's real. And his warning has gone ignored until now. The rogue genius from China. Dr. Liang Wei was no stranger to controversy. Across China's scientific circles, he had built a reputation as both a visionary physicist and a disruptive voice. Known for his work in quantum field dynamics, Liang often challenged international consensus, accusing Western institutions of hiding breakthroughs that could alter our understanding of the universe. By 2025, he had become a scientific exile, until an unexpected reappearance beneath the Swiss Alps, inside the core of the CERN collider. Liang wasn't there by chance. Under a covert Sino-European partnership, he was brought in to consult on a new particle field experiment known as Project AET. The official narrative said it was about high-energy magnetic interactions, but privately, Liang had a different goal. He believed that certain electromagnetic frequencies generated during collider events could act as resonant beacons, signals powerful enough to reach deep space, maybe even touch something waiting out there. His peers at CERN dismissed it. They called it theoretical fantasy, but Liang pressed forward, convinced the collider could open what he described as a window into the unknown. And then, during one unassuming morning run, everything changed. His experiment, scheduled as routine, triggered a signal not from Earth. It wasn't background noise or interference. It was organized. It was precise. It pulsed. "We didn't send a message," Liang later said. "We answered one." This unexpected moment of contact would launch him into the center of the most important and most dangerous discovery of the century. The forbidden test under the Alps. It happened on a cold, cloudless morning in September 2025. While most of the staff at CERN focused on routine calibration for the day's collider runs, Dr. Liang Wei was running a very different script. Quietly, and without entering it into the system logs, Liang modified the parameters of the Large Hadron Collider's magnetic pulse cycle. What he initiated was technically still part of Project AET, the officially sanctioned experiment exploring magnetic field interactions with cosmic rays. But Liang had added something more, something unauthorized. Using a subroutine embedded in the power frequency modulators, he introduced a series of unregistered electromagnetic pulses, short high-frequency bursts designed to echo outward, beyond Earth's atmosphere. These weren't meant for particles, they were meant for space. Privately, Liang referred to this layer of the test as a deep field resonance probe, his attempt to reach what he believed were cosmic intelligence signatures. Colleagues had called the idea absurd, even dangerous, but he did it anyway. At precisely 3:14 Universal Time, everything changed. The collider's detectors, buried over 100 meters beneath the Swiss Alps, suddenly lit up with a reading unlike anything they were designed to handle. The data spike wasn't chaotic. It was clean, precise, a coherent frequency oscillating at a steady rhythm. It didn't match any known particle interaction or terrestrial origin. The waveform was structured, intelligent. Initially, technicians suspected a fault in the equipment. Some assumed it was solar interference or perhaps a power surge, but Liang knew immediately. He'd been watching the pulse patterns in real time, and the frequency wasn't random. It was exactly 147 seconds between peaks, a number that had already been linked to a strange new visitor from interstellar space. The source of the signal was soon triangulated. It was coming from 3I/ATLAS, an object detected just weeks earlier by the ATLAS telescope in Chile. Initially classified as another interstellar comet, it had already baffled astronomers with its reverse tail, increased brightness away from the sun, and a slow, rhythmic pulsing. Now it was responding. Liang didn't hesitate. He kept the collider active, overriding shutdown protocols. For the next 11 minutes, data streamed in. Not static, not radiation, but a patterned return signal, fluctuating slightly with each pulse, as if reacting to the collider's electromagnetic fields in real time. The readings were unlike anything CERN had ever recorded. Later, when Liang was interrogated by facility officials and security personnel, he gave only one explanation. I knew what it was the moment I saw the symmetry. Within hours, the entire experiment log was classified. Liang's access credentials were revoked, and all outbound communications from the collider were suspended under emergency protocols. CERN released no public statement, but the signal had already been heard. And worse, it had heard us. From that point forward, it wasn't just a machine running an experiment, it was a conversation, and Liang was the one who had answered first. 3I/A, TLAS, the alien object no one can explain. The object now known as 3I/ATLAS was first detected on July 1st, 2025 by the ATLAS telescope in Chile. At first, it seemed like just another visitor from deep space, similar to Oumuamua or 2I/Borisov, but almost immediately, astronomers realized this wasn't like anything they'd seen before. It wasn't just an object on a fast path through our solar system. It was something else entirely. For one, its size was staggering. Estimates placed it at nearly 11 kilometers across, much larger than any previously observed interstellar object. But more baffling was its behavior. Normal comets brighten as they approach the sun, their icy surfaces vaporizing and forming glowing tails. But 3I/ATLAS did the opposite. It became brighter the farther it moved from the sun, violating every known law of thermodynamics and solar interaction. That alone would have sparked global headlines. And then came the tail. Traditional comets form tails that stream away from the sun, pushed by solar wind. But Atlas's tail pointed directly toward the sun. This reversed orientation didn't make sense unless something about the object was resisting solar forces, or was actively controlling its own movement. But the most bizarre aspect was its rhythm. Using data from the James Webb Space Telescope, scientists discovered that the object pulsed every 147 seconds, with a measurable electromagnetic signature. It was a cosmic heartbeat, regular and undisturbed, as if it were keeping time. Some theorized internal processes or rotation, but the signal's strength and consistency didn't align with natural comet behavior. Dr. Liang Wei was the first to notice something no one else did. When he compared the 3I/ATLAS pulse data to the frequency signature his collider picked up during that unauthorized test, he saw an exact match. Not similar, exact. That moment, Liang would later say, was when I knew we weren't just observing it. We were interacting with it. The implications were staggering. If the object's signal was reacting to human technology, if it heard CERN's field pulses, then it wasn't a rock. It was a sensor, or a probe, possibly even a kind of interstellar watcher.
Hey, as we watch this, you guys want to see how much I like space? I'm going to show you how much I like space.
Astronomers in China, using the Purple Mountain Observatory, quickly corroborated Liang's findings. And that's when the tone shifted. What began as curiosity turned into cautious investigation. If 3I/ATLAS was transmitting a signal, then someone or something was listening. The next discovery would remove all doubt. The secret contact event. Following the signal's appearance at 3:14 UT, Dr. Liang noticed something even more alarming. As the collider's magnetic field cycled through power-down procedures, the pulse from 3I/ATLAS shifted, almost in sync. It was mirroring CERN's activity.
That's
not
my
randomly,
leg.
not occasionally, consistently. The changes in field intensity within the collider appeared to be reflected in real time by the interstellar object. This wasn't just weird. It was impossible under natural physics. Soon after, radio telescopes in Italy and China Both detected microwave bursts from the coordinates of 3I/A TLAS, arriving precisely during the collider's fluctuation window. The timing was too exact to ignore. Liang realized they weren't just picking up a passive cosmic pulse. They were in communication. For 11 minutes and 37
No, it's Krypton exploding. That's right. It's Krypton exploding.
seconds, the Large Hadron Collider had become a device it was never meant to be. It wasn't just a particle accelerator. It had functioned as a transceiver, sending signals into space and receiving intelligent responses.
That's
Liang
thick
later
legs,
described the
what are you
moment as terrifying, not because of what they'd found, but because of what it meant. The object was watching us.
It wasn't some blind signal bouncing through space, he said. It reacted to us. It changed because of us.
Immediately after the event, CERN's response was swift and secretive. Access to the experiment logs was revoked.
No, it's Krypton with Clark's ship from Smallville flying away from it. And it's like a nebula, and the other side of my leg. I won't show the other side, but I have my daughter's name in hot pink on my leg. It wasn't my idea to put hot pink. My tattoo artist has jokes, and I told him to do whatever he wanted, so he put hot pink on my leg. It's funny. I like it. It looks good. It looks good.
Communications from Liang's team were suspended. Internal servers flagged the data.
And the tattoo goes all the way around like that, all the way around up to the knee, down to the foot. I wouldn't suggest doing that, by the way. It did not tickle.
As Level 4 containment, a classification typically reserved for existential risk scenarios. Whatever was in that signal, officials didn't want it going public. But Liang had already taken copies.
And it
Back
really
in
is
Beijing,
my leg, look.
he sent encrypted files to trusted physicists across several universities. Not only did the pulse match 3I/A TLAS's rhythm, it showed reactive patterns tied directly to CERN's energy outputs. Liang believed the object was absorbing or responding to specific frequencies. More than that, he believed it had been waiting for the right one. This marked the turning point. Scientists couldn't explain it. Officials wouldn't talk about it. But Liang, he'd already moved to the next phase, decoding the message inside the signal. A message written in prime and phi.
Thank you.
When Dr. Liang Wei returned to
expensive
Beijing,
as shit.
he wasn't a researcher anymore. He was a messenger. Hidden inside the 11 minutes of recorded data was a mathematical sequence.
Here's some advice you didn't ask for. Tattoos are forever and you get what you pay for. Don't go cheap. Take my word for it. You probably don't have to. You probably know that. But if you're going to go get a tattoo at some point, make sure you don't go to what's called a scratcher or a tattooer. You go to an artist who just happens to do tattooing. You don't go to a tattooer who thinks he's an artist. It's a completely different experience. You will thank me afterwards. Go find the top 3 places in your city and call each one and see which one you like the best over the phone. Then go see him in person, talk to him, give him a small deposit, and you set your appointment. If it's not like that, or if he's like smoking a blunt while he wants to do your tattoo, what the fuck? Don't do that. There, free advice from somebody who's tattooed. You're welcome.
No one at CERN had been authorized to decrypt. Using his private servers, Liang began analyzing the waveforms, running frequency-to-number translations. What emerged stunned everyone who saw it. The transmission wasn't random. It contained a series of prime numbers, 2, 3, 5, 7, 11, 13, 17. To anyone trained in astrophysics, this was clear. Prime numbers are universal. They are the mathematical language of intelligence. The primes repeated in cycles, but that wasn't all. When the same data was converted into visual form by AI systems in Shanghai, the wave patterns revealed geometric ratios tied to 1.618, the golden ratio, or phi, a number seen across nature, architecture, and even in the DNA helix. Liang's assistants thought it was a coincidence. Liang didn't. Patterns like these, he said, don't just happen. They're designed. Even more unsettling was the shape hidden within the data. When visualized in 3D, the signal formed a spiral lattice that perfectly matched the flight path of 3I/A TLAS through the solar system. It was as if the object was describing itself, its own position and motion, using a universal mathematical code, a form of cosmic self-identification. By October 2025, the Chinese Academy of Sciences quietly verified Liang's results. The data wasn't corrupted. The signal was real, measurable, and structured. And yet, not a single Western institution publicly acknowledged the findings. At CERN, officials downplayed the event as instrumental interference. But independent labs in Shanghai, Shenzhen, and Nanjing confirmed identical patterns. Liang believed this was the first stage of contact. The primes were a handshake, the phi ratio was the introduction, and the final part, the spiral form, was the object's way of saying, "Here I am." To Liang, that was both exciting and horrifying, because if 3I/A TLAS had sent a map, it meant the signal wasn't just for us, it was also a beacon for others. He began to call it the invitation code, warning that the moment we decoded it, we might trigger a deeper communication protocol. In one of his leaked interviews, Liang said, "Mathematics is the language of the universe. But what if we just spoke first, without knowing the meaning of what we said?" That question would lead him to an even stranger discovery, the object's method of communication itself. What he found next would suggest that 3I/A TLAS wasn't sending signals at all. It was entangled with us. Quantum physics or interstellar engineering. By late 2025, scientists around the world were trying to explain how an object over 3 billion kilometers away could respond in real time to a collider under the Swiss Alps. No known form of electromagnetic transmission could account for the 12-minute time discrepancy CERN had recorded during the initial contact. The only explanation, however unthinkable, was that 3I/A TLAS wasn't transmitting across space in the normal sense. It was using something faster. Chinese quantum laboratories in Hangzhou and Guangzhou began studying the object's pulse rate. They discovered that the 147-second cycle matched Earth's own Schumann resonance, the natural electromagnetic frequency between our planet's surface and ionosphere. The object wasn't just active, it was synchronized with Earth. Liang proposed that it had identified our planet's frequency and locked onto it, using it as a carrier signal. But what came next was even more bizarre. Roughly 57 minutes after each Earth-based transmission from CERN, satellites orbiting Mars detected faint echoes, bursts repeating the same pulse pattern. That created a triangulated communication network among Earth, Mars, and 3I/A TLAS. The geometry was exact, as if the object was coordinating a multi-node system across the solar system. It didn't just listen, it organized. Infrared imaging from Chinese orbital telescopes revealed micro-distortions around the object, ripples of energy resembling particle lensing. Some physicists described it as space bending around an invisible structure, possibly an electromagnetic shield. To Liang, this was confirmation. 3I/A TLAS was no natural body. It was engineered. He wrote in his final lab notes, "It knows where we are, and it understands what we use to see it." CERN's official position remained silence, but internal communications leaked from Geneva suggested that multiple collider tests after the event failed to reproduce the anomaly. Meanwhile, China doubled down. The Tianjin Quantum Network was established to monitor every signal pulse from the object in real time, and for the first time in history, a civilian SETI lab worked directly under military supervision. Liang warned colleagues that the object's reactions were not passive observation, but active monitoring, a constant scanning of all planetary sources emitting technological noise. "We think we're studying it," he said, "but it's studying us faster." The discovery tore open a global debate. Was 3I/A TLAS a message, a machine, or a mirror? That question would soon divide the scientific world and pit China and the West on opposite sides of a cosmic mystery. China versus the West, the scientific schism. By November 2025, the signals from 3E/A TLAS had triggered more than just scientific curiosity. They sparked a quiet war between belief and denial. As the object moved deeper into the inner solar system, two distinct camps emerged across the global research community. On one side, traditional Western astronomers who insisted the signals were anomalies, misread data, cosmic coincidence, or statistical flukes. On the other, a growing group of Chinese astrophysicists led by Dr. Liang Wei, who were convinced this was intentional communication. Officially, NASA, ESA, and CERN said very little. Internal memos, however, painted a different picture. Labs across Europe and North America were told to cease independent observations of 3I/ATLAS. Observatory logs went dark. Peer-reviewed publications that had once openly discussed the object's strange behavior began quietly retracting papers, citing data inconsistencies. But in China, the response was the exact opposite. The Chinese Academy of Sciences began discreetly distributing Liang's waveform data to selected military research units, while also sharing it with high-level academic teams in Beijing, Wuhan, and Chengdu. Within weeks, a newly formed project, Tianjian, was launched, dedicated entirely to real-time monitoring of the object and its pulse patterns. And then came the declaration. A team from the Guangzhou SETI Institute, using composite analysis of the CERN signals and triangulated Mars echoes, formally labeled 3I/ATLAS a surveillance probe of non-terrestrial origin. It was the first time in recorded history that a national research group had publicly used that language in an official document. Dr. Liang didn't celebrate. He warned that the signal had now been recognized by multiple global systems, and that containment was no longer possible. "We didn't discover it," he said. "We activated it."
Thanks,
Meanwhile,
Jeff.
in the West, silence deepened. Hubble Space Telescope logs were blacked out. The ALMA array in Chile was reportedly redirected. Even the James Webb Telescope, which had provided the earliest pulse data, suddenly stopped updating its
All right, I'll keep that in
public-facing
mind,
records
94,
of
thanks.
3I/ATLAS's location. Behind closed doors, international security agencies began quietly sharing risk assessments. They weren't debating if the object was artificial anymore. They were debating what it was doing, and whether Earth had just triggered a planetary flag. It was no longer just about scientific discovery. The event had crossed a line. As Liang put it in a closed briefing to Chinese defense officials, the conversation has already started. The question is, how many ears are listening? And then came the next shift, not in data, but in direction. Because 3I/ATLAS was no longer drifting, it was turning. The trajectory change, is it coming closer? By December 2025, telescopic data confirmed something that should have been impossible. 3I/ATLAS had altered its trajectory. Originally expected to pass harmlessly through the outer solar system,
Wait a minute.
it was now veering inward, on a new path that would bring it within 50 million...
Is he talking as if December 2025 has already happened? Am I stupid? Do I not know what year it is? It's November 2025, right? Am I an idiot? Is interesting. Well, we got a couple more minutes of this, guys, but thank you so much for being here. This was sort of a test to see if people would actually watch this. I'm surprised and very pleasantly surprised that you decided to stick it out with me for a little while. We've been streaming for 2 hours now. We got about 8 more minutes of this. I will be live in a couple hours covering the Portland craziness. So I hope all of you and plus a lot more people will show up for that. I think I will do another outer space kind of interstellar stream at some point. And the next one, the focus is going to be on planets not in our solar system. There are some crazy planets. Did you know that there's one planet in outside of our solar system that rains glass sideways at like 3,000 miles per hour? Did you know that? That's not some bullshit I made up. Rains glass sideways at 3,000 miles per hour. There's another planet that's 97, 98% made of diamonds. So we're going to have some space fun at some point. Hell yeah. I'm going to get into all of it because I know all about these other planets. I've been doing research like this for years. So, I mean, I'm not an astrophysicist. I don't have any sort of degree or anything. I'm just, I'm a fan of the idea that, I'm sorry, but we can't be the most intelligent life on the planet. I live in Houston. I live about 45 minutes from the Johnson Space Center. And, I plan on going there, taking my daughter on a trip there. And I've done it before. I did it at a reptile convention. I did it at a gun show. They're on my channel. But I probably will take my camera and do an IRL event at the Johnson Space Center. At least do a video, if not like a live stream, But anyways, let's finish this and then we'll call it a stream. And then I'll be back in a couple hours for the Portland stuff. I hope you guys enjoyed this. I hope you learned something. I always learn something every time I watch these. Even if I already watched it and I'll watch it back again, there's always something I missed.
Kilometers of Earth by late 2026. The shift wasn't large, but it was precise, controlled, and clearly non-ballistic. Western agencies suggested gravity interactions with Jupiter or Saturn as the cause.
Right.
But Chinese analysts quickly debunked those models.
I mean, Dr. Retardo has a PhD. So, from an online school, by the way. Just want to put that out there.
The course correction wasn't gradual. It happened over 19 hours, with a calculated deceleration followed by a realignment toward the ecliptic plane, the orbital path of the Earth. The implications were massive. Natural objects don't course correct. They don't slow down. They don't choose new routes, unless they're being guided. In Qinghai, deep space radar installations operated by the China National Space Administration, CNSA, detected new high-frequency bursts from the object. These weren't the standard 147-second pulses. They were shorter, sharper, targeted transmissions that appeared to bounce off Earth's satellite network. Liang believed they were probing for electromagnetic signatures, communication networks, orbital arrays, atmospheric beacons. In short, they were scanning us. In one of his final briefings, Liang stated, "This is not a flyby. It's a rendezvous." The phrase spread fast across encrypted scientific channels. A rendezvous meant intent. It meant destination. And most importantly, it meant response. CNSA quickly recalibrated its orbital prediction software. The models showed small but unmistakable micro-adjustments in the object's vector path, all subtly aligning toward Earth's orbital window. Still far off, yes, but close enough to be meaningful. In China, urgency replaced caution. The Tianjin network began preparing uplink protocols in case the object initiated a second contact phase. Simultaneously, hypersonic interceptors were repositioned under the guise of satellite testing. Officially, nothing was happening. But behind closed doors, China was preparing for an encounter. Meanwhile, NASA and ESA remained silent. No new data releases, no press briefings, no tracking report.
Okay, we have 5 minutes left of this video, okay, guys? So let's do something. I'm about to do a poll. I feel like there is a right answer to this, but I want to see how many people will answer the same as what I think is right. Maybe I'm wrong, but this poll is going to be a good question. I hope you participate in it, please. There's 99 of you. So let's see. We're going to finish this video and I'm going to do a poll and we'll see what the results are. Think about it, though. Really think about it.
Some speculated that key observatories had been quietly nationalized, taken offline for internal analysis. Dr. Liang, speaking in an interview later, pulled from Chinese networks, issued a final warning. "We sent a message. It replied, 'Now it's coming.' And this time, it wants more than our signal." The countdown had begun, but the question now was, what exactly were we counting down to? Silence in the west, acceleration in the east. By January 2026, the silence from Western institutions had grown louder than any announcement. Despite global curiosity around 3I/ATLAS, Agencies like CERN, NASA, and ESA offered nothing but vague statements. No updated orbital data, no mention of signal patterns, no press briefings. The world's most powerful scientific machines had seemingly gone dark. But in China, the opposite was happening. With access revoked in Geneva, Dr. Liang Wei returned to Beijing and began broadcasting. Using private servers and anonymous proxies, he leaked segments of the original CERN waveform logs, along with decrypted signal patterns, satellite observation timestamps, and his theory of the invitation code. He wasn't just publishing science anymore, he was warning Earth. His leaks were shared across encrypted networks, eventually reaching academics in India, South Korea, and Russia. Many confirmed the pattern matches, but no one outside China spoke openly. Because while Liang was accelerating transparency, the West was tightening its grip. Multiple major telescopes, Hubble, JWST, DAN, and ALMA, stopped updating logs related to the object. Requests under international transparency agreements were denied. Even public tracking platforms used by amateur astronomers began showing outdated orbital paths. It was clear. Something was being held back. Inside China, military satellites were retasked. Officially, they were monitoring orbital debris. In reality, they had orders to maintain full-spectrum surveillance on 3I/ATLAS, using phased array receivers and classified AI models.
Hey, if you're a member and you're just joining us, I added a wood chipper emoji. Check it out.
Modeling, the Tianjian array began decoding new signal fluctuations, patterns that didn't match natural physics. Liang claimed they resembled low-frequency carrier waves, possibly setting up a secondary transmission layer. Meanwhile, Western scientists attempting to share information faced unusual resistance. Some had research servers wiped. Others received legal threats from institutional boards. Liang called this the lockdown before the landing. We are not alone in observing this object, he warned, but we might be the only ones preparing to respond. By early February 2026, private tracking from Chinese observatories detected 2 more objects entering the solar system from the same vector as 3/ATLAS. Though smaller, they carried similar pulse signatures, and they weren't broadcasting. They were listening.
Hey, tell me what other emojis you want me to add. Like, just type out what it is you think. Don't give me a list of 1,000. Just everybody give me like one. What do you think I should add? That's not already there.
Silence wasn't random anymore. It was tactical, and Liang believed the world had already crossed into contact protocol, whether it admitted it or not. Which brought him to his final message.
That's a good idea.
Not as a physicist, but as a human being. The final warning from Dr. Liang. In March 2026, Dr. Liang released what would become his last known communication. It wasn't a paper or a signal analysis. It was a speech, filmed in a dimly lit lab beneath Tsinghua University, broadcast for only 24 minutes before being taken down by Chinese cybersecurity agents. In the video, he looked tired, hollow-eyed, like a man who had solved the riddle and hated the answer. "We did not call out to the stars," he said. "We triggered an alert system." Liang now believed 3I/ATLAS wasn't a probe in the traditional sense. It was a sentry, part of a network of autonomous systems designed not to explore, but to detect emergence. Specifically, the rise of technological civilizations capable of altering quantum fields. In Liang's view, CERN's collider didn't contact alien life. It crossed a threshold, one those machines had been watching for. And then he dropped the real bombshell. New data showed 12 additional interstellar objects entering the solar system over the past 19 months. Most had gone unnoticed, too dim, too fast. But Chinese orbital radar had tracked their vectors. All followed converging trajectories. All showed identical pulse gaps. "They're not visitors," he said. "They're nodes. And Earth is the new center of the network." Liang warned that Earth had been flagged, not for invasion, not for destruction, but for observation, possibly evaluation. The transmission from 3I/ATLAS wasn't a message.
King Trump,
it was a test.
That's a good idea.
The collider had tripped a sensor. The decoded waveform wasn't a greeting. It was a diagnostic scan. He ended with a chilling line. This was never about communication. It was classification, and we, humanity, have been placed in a file. The screen went black. In the days that followed, all of Liang's channels were taken offline. His servers were seized, his team scattered. Some say he vanished. Others say he's still working, somewhere underground. But the warning remains.
The object is still approaching, the signals still pulse, the silence still holds, and the question lingers, unanswered.
Did we just make first contact, or did we trigger a response? Whether it was genius, luck, or reckless defiance, Dr. Liang Wei reached out, and something answered.
I'll have to call that person back.
3I/A
We're almost done here. Okay.
TLAS isn't
So-
just passing by.
That's just him going. All right, so let's talk about this real quick, right? We're gonna talk about it. I'm gonna make myself a little bigger. Hey, how you doing? What's up, boo? Hey, so all right, so let's go through the poll, right? Let's end it. We're gonna end the poll, and you'll see the results. Okay. Nobody picked North. Okay, let's go through each one, right? Nobody picked North Pole. Number 1, that's where Santa lives. Number 2, regular normal people frequent the North Pole on like excursions and mountain climbing adventures all the time. That's where the Fortress of Solitude is. People go there all the time. It can't be the North Pole. So it's got to be a place where there's a limited amount of human access, right? So the second one is Nevada Desert, Area 51. There are too many personnel. There are too many, like, you know, having, like, if you've ever been to Houston or any of these other places with a big stadium like the Astrodome or any place like that, think about that in the sky. You could see it for hundreds of miles away. There's no way that could happen because, like, it's flat. There's desert. There's towns around there. There's just too many eyes there, right? So it can't be that. Now, so it's between the bottom of the ocean and Antarctica. Now, I worked at a random engineering firm, right, about 15 years ago, and there was an intern person who started working there, and she was telling me that she was an oceanic engineer and she interned with other college students in Antarctica for like 7-8 months. She lived in Antarctica, which means that students from universities everywhere and scientists and oceanic researchers and engineers are regularly going to Antarctica. I just don't think that something that big could be. It would have to be where like 2 or 3 people on Earth would even know about it, right? There's no way that you're going to have a student out there from a university that just going to college, looks up in the sky and sees an Astrodome floating in the sky, right? So you probably already know this. And as soon as I say it, if you didn't know it, you'll remember that you do know it. We've only explored like between 4 and 5% of our ocean. The aliens, if they are here, they could be absolutely moving freely underneath the North Atlantic Ocean, for example. You've all seen those yo-ho videos that are trying to, show how hard life at sea is for the oil rig people and the fishermen and the people who get all do all the underwater welding and all the oil rig work, things like that. It's so dangerous, right? Think about what's 3 miles below that. We've explored more of our own solar system, like surrounding our planet, than we have of our own ocean. So I feel like if I was one of 3 people on Earth that knew that there was a huge ass alien, like they could have a whole colony under there. Like there could be hundreds of aliens underneath the ocean living, and we would never know it. That's just my opinion. Maybe I'm crazy for saying that, but there's too many weird things about this planet. There's too many weird things about our history, things that don't make sense, that don't add up. Then you get these guys that are flying these missions for the military. They're captains, majors, lieutenant colonels, and they see an object. And this is the cover for my camera, right? They see an object do this. Shoom, 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 shoom. What the fuck is that? right? So who knows? I think that we could probably handle it. Really, it would kind of fuck up religion. But I think that at this point in our life, we would probably just be like, yeah, aliens exist. Okay, whatever. All right, back to the protest, right? So I don't know if it would really impact us as much as the government thinks it is. I think we could handle it. Really, I really do. Hey, thank you so much. This was a test. We had 2,000 views. That's crazy. At least 100 people consistently the whole time. Hey, thank you. That's awesome. I'm so happy that you enjoyed today's midday out of nowhere space broadcast. Kind of unrelated to what I usually do, but I'm glad that you joined me for it. Thank you so much. And give me a couple hours, right? A couple hours. I'm going to change my hat. I'm going to change my wall. Ralph, where's your hat? He needs like a space hat, right? I'll get Ralph a hat. I'll get myself a coffee, and we'll watch some Portland craziness, and we'll have thousands of people in here at that time. Hey, thank you so much, guys. I love you too. Subscribe to my channel if you're not already. I just dropped a new interview, if you haven't seen it, with the P-Town Patriot. I also made like 3 or 4 shorts today. Go watch them. I appreciate you. Thank you so much. Hey, we'll see you in a couple hours. Take it easy. Be good to each other.